Welcome to Computer Science AS Levels, chapter number 12, Software Development. In this lesson, we are going to continue the topic of pseudocodes, and we have done this algorithm with the function. Right here, we have a function called calculate volume. Today, we are going to continue with the procedure. What is the difference between function and procedure?
In procedure, you don't get a value in return, and in a function, you get a value in return.
Excellent. Perfect answer. Perfectly said. So this is a difference between a procedure and a function, that we are going to return our value in a form of a data type. Right here, we have a procedure. In this procedure, we are going to find out the radius. So we use input radius as a variable. Then we are using print output. Please enter the radius of the sphere. This is a message which will be print on the screen. And then you're going to input the radius. So right here, radius is a variable. And we have to calculate the radius here. So we take it as a procedure. So while a radius is lesser than 0, instead of while, we can use if as well, okay? Right? While basically is a loop.
Yeah.
While do is a loop, right? So while radius
Yeah.
is lesser than 0, so definitely it is not possible that radius is equal to 0. Sorry, lesser than 0. If it is lesser than 0, it will be a negative number. Remember the number line? Look, -1, -2, -3. And if we process above, so the values are positive. Look. So if the number is lesser than 0, it means it is a negative value. So the message will be displayed. Please enter a positive number. So the radius will be any positive value. Did you understand this logic?
Yeah, I get it.
Right? Okay.
Basically, a value less than 0 can't be entered. If it is, then you need to output an error.
Definitely will not take that value. So again, you have to input the radius. Then and while and procedure. So this is how the procedure is going to be stopped here. Then you're going to print the value of the procedure. So procedure, output, answer. So whatever the value of the radius, that value displayed as an answer. Output, answer, and procedure. So this is how we are going to use the modules for input and output. Basically, we are learning the input and output procedures here. You can see here how to input the value of the procedures and functions, and how to output the values of functions and procedure. The last lesson, we have covered this one. Okay, now proceeding. Purpose and use of state transition diagrams. Okay, do you remember the state transition diagrams topic? State transition diagram, the diagram we have. Just let me show you.
I remember the structure diagram. I don't.
Okay, I'm sharing with you. Okay, we are about to start this. State transition diagram. Very important topic. Sure. Okay. Let me move this topic to the next page. Okay, basically, state transition diagram is a method representing the scenario of any operation like this. This is called state transition diagram. And in this figure, you notice you got some instructions. So you are going to represent a scenario in a way like this. This whole thing is called state transition diagram. So we are going to start this topic right now. A finite state machine, FSM, is a mathematical model of a machine that can be in one of a fixed set of possible states. What does it mean? Let me tell you. Let's suppose you have a machine and that machine is being operated by some inputs. Like if you have a kind of a door which is protected by a key, like in a hotel, you visited hotels, you stay in the hotels. So for a room, the hotel management give you a key or a card. You're gonna swap that card into the machine and the door will be open. Is that happened with you ever? It's a very normal thing. In a
Yeah.
hotels, if you visited any hotel like Marriott, Pearl Continental hotels like that, so you book a room there. So you got a card or a key card. That key card you just move or swap into a machine, the room door will be open and you can enter. Similarly, if you have a kind of a bank locker, the bank locker. So a locker is being protected by a key. The key you have to be entered on the locker and the locker door will be open. Did you get this idea now?
Yeah, I get it.
So many of the machines like that are being operated by this scenario. You have to input the password and the door will be open, just like this. So this is called a finite state machine in which there are the possible numbers which have been entered into the machine and the door will be open. Like, did you see kids have a tiki bank? In that tiki bank, the kids have to open some password, fix a password into the tiki bank. So they are going to fix a password like 123. The bank tiki bank will be open, and you need to put the money in it and close it again. So this type of machines are called FSM, finite state machine, in which the user have to input the password, and the password will be accepted, and the machine will take it and open. So one state is changed to another state by an external input. This is called transition. Yes, let's suppose this is a door. Hello, Aisha, how are you? This is
I'm good, sir. How are you?
Alhamdulillah, dear, I'm fine. This door is protected by a password. The password is 1, 2, 3, and 4. So there is a padlock. In this padlock, you have to you have to input the password. So you need to write 1, 2, 3, and 4. Once you entered 4, the door will be open. Did you get this idea, guys?
Yes.
Yeah, I see.
Very simple thing. It's a very simple thing, guys. Okay. Achha, now what happened? Once I press 1, the computer knows this password and the condition is matched. Look, this is my stored data. 1, 2, 3, 4. This is my stored password, right? So once I look, input 1, the computer is going to match the entered value here. 1. So it is true. Now the computer will proceed you to the next stage. What is the next value I have to enter? Tell me.
2.
2. So once I press 2, the input is gonna be matched with the already saved value 2. And computer accept this value and proceed you to the next input. What is the next input?
3.
3.
So I have to press 3. So look, if I'm
I was the host for some reason in the meeting, so I changed it.
I'm not able to hear you clearly. Can you send me your voice on the group?
No, no, no. I was saying that I was the host of the meeting, so I made I
Okay,
changed
okay.
it.
Did you transfer me the control? Yes, I
Yeah,
got it.
yeah, I changed it.
No problem. Thank you very much. Okay, guys, now we are going to continue the topic of state transition diagram, right? So I'm teaching you that finite state machine is a kind of a state, right? In that state, we are having a scenario, right? In that scenario, we are going to operate any machine or any structure with the help of some given inputs, like a password. And I told you that like automatic doors have a password. You need to input the password and the machine will be on, or you can say the door will be open like this. So This is called FSM, right? And once we are going to input the password, like I teach you about the door have a password. As I told you, the door have a password. This is a door. In this door, we have to input a password. 1, 2, 3, 4. This 1, 2, 3, 4 value is already stored. So while the user is going to input the password, 1, then 2, then 3, and then 4. So the computer is going to accept the input one by one. This acceptance is called transition. This acceptance is called transition. Right? So basically transition का मतलब क्या होता है? एक जगह से दूसरी जगह डाटा को भेजना, राइट? अगर हम नॉर्मल बात करते हैं तो ट्रांजिशन का मतलब क्या होता है कि हम एक जगह से दूसरी जगह डाटा को भेज रहे हैं. Right here transition means sending the control to the other value. So first input is 1, value input the next value, the transition is being sent to the next input, then next and then next. So a diagram showing the behavior of an FSM is called state transition diagram. So ऐसी diagram जो इस पूरे structure को specific symbols के जरिए represent करती है, like this guys, like this. This type of diagram is called state transition diagram. Any confusion?
Okay. No.
Clear. Aisha.
No, sir.
Okay.
So I have one question though.
Yes.
So as you said, like when you go 1, 2, 3, 4, you enter the input 1 and then it matches to 1. But there's some doors that have like passwords that when you type the entire password, then it tells you that the passcode is correct or no. So will the same method be used for them too?
देखिए, it depends upon the backend program, like how the programmer developed that. Basically, once you input the password, there is a validation check working behind it. What check? Validation check.
Yeah.
So validation check working depend upon how the program is designed. If I design the program like first there's a passcode 1, 2, 3, 4. So the computer is going to check your entered value with the already stored values. This is mandatory, but this is a back-end working. We don't know कि पीछे प्रोग्रामर ने क्या वैलिडेशन सेट किया है. अगर प्रोग्रामर ने वैलिडेशन ये सेट की हुई है कि चारों इनपुट पहले यूजर कर देगा और फिर कंप्यूटर चेक करेगा, तो डिपेंड्स. लेकिन दोनों ही सिनेरियो में स्टेट ट्रांजिशन डायग्राम काम कर सकती है, राइट? लाइक बायोमेट्रिक्स तो है, लेकिन बायोमेट्रिक्स हमारे पास दूसरा सिनेरियो फॉलो होगा, ठीक है? रेटिना स्कैन में हमारे पास कोई और सिनेरियो फॉलो होगा, ठीक है? जो पासवर्ड इनपुट है उसमें ये होगा, राइट?
Okay.
बहुत सारी आजकल जो कार्स आई हैं, वो कार्स क्या है, वो बायोमेट्रिक पर चल रही है ना. लाइक यू जस्ट प्रेस पुट द थंब इन अ सेंसर ऑफ द कार एंड द कार इंजन स्टार्ट्स. ऐसा भी है, अनस्टीलेबल कार्स कहते हैं ऐसी कार्स को, ठीक है? सो टेक्नोलॉजी यार इतनी तेजी से चेंज हो रही है कि बहुत सारी चीजें तो हम कवर ही नहीं कर सकते, राइट? डे बाय डे द थिंग्स आर गोना बी चेंज, एडवांसमेंट, राइट? सो डिपेंड अपॉन द बैक एंड प्रोग्रामिंग, क्या प्रोग्रामर ने क्या चीज सेट की हुई है. ठीक है जी, आगे बढ़ जाऊं?
Yeah.
अच्छा भाई, अब देखते हैं ये स्टेट ट्रांजिशन डायग्राम होती क्या है. अभी तक तो हमने सिर्फ इसका एक सिनेरियो समझा है. सो अ स्टेट ट्रांजिशन डायग्राम can be constructed as follows. So how do we construct it? Let's see, guys. Number one, states are represented as nodes. So whatever the states are there, the conditions are there, they are represented by the circles, right? They are represented by the circle, right?
Yeah.
Let me draw it for you guys. Okay, let's So right here, you can see here circles are there. So these are the states. So states are drawn in a form of circles, right? These are also called nodes. Nodes. Okay. Number two, transitions are represented as interconnected arrows. So guys, if they are connected, the arrows are there, which are going to represent the transition between them like this. Okay. Maybe it can be drawn like this. Right, guys? So this is how the arrows are being drawn. Okay, okay, number third.
Okay.
Events are represented as label on the arrows. Events. What do you mean by events? Events means happening. Like what is happening here? Like you are going to input A. So this is right here 0. You are going to input A. So look, this is an event. Event means the steps, whatever it is going to be take. So it's from 0 or from 0, you're going to input A or 1 here. So if you're going to input 1, so look, the event happened. This is called event. So whatever the instructions written with the arrow, down or up, it will be considered as events. Okay? Event changes. Conditions can be specified in square brackets after the event labeled. Yes, if there are any conditions, so the conditions can be written like this in a square brackets. So with the event, there are some conditions. The conditions are represented in a square brackets. So they are called conditions. Next, the initial state is indicated by an arrow with a black dot. What does it mean? It means that state transition diagram is being started with the help of a black dot with an arrow like this. So once you see this thing, it means this is the start point. Is it okay, guys? If you see an arrow with a black dot, it means it is a start. So I'm going to write start. Next, the stop state is indicated by a double circle. Yes, if your state transition diagram is going to be stopped, so you're going to represent it with the double circles, with the 2 circles, like this. It means it is going to be stopped here. So maybe the circle is big or small, doesn't matter. If you see the 2 circles, one into another, it means you have to stop. Is that okay, guys?
Yes.
Okay. Acha ji. Now what you have to do, you need to write it down first. First, you need to write down state transition diagram introduction. Once you're done with this part, let me know. So I will move you to this part, okay?
Okay.
Okay. Now, the algorithm for unlocking a door using a 3-digit entry code can be represented by a state transition diagram. So guys, now we are going to take an algorithm. In that algorithm, we have a 3-digit code, right? In that code is being represented by a state transition diagram. If the door is unlocked with a 3-digit entry code, the lock can be in 4 states. How? Like we have a 3-digit code. Let's suppose 1, 2, 3. 3 codes will be entered. And they are saying the lock can be in 4 states. Let's see how. Number 1, locked and waiting for the input of the first digit. So look, the door is locked here. I just write L here. L means locked. Say it, locked. So it is waiting for the first input. So the user have to input the first number, right? Waiting for the input of the second digit. So if the first number is input, let's suppose the first number is 2. So it is input. Now the computer is waiting for the second value. Second value is, let's suppose, 5. Okay, then waiting for the input of the third digit. Now it is waiting for the third digit. Look, third digit 9. Let's suppose the third digit is 9. So 259 is a code. Then what happened? The door will be unlocked. So how many steps are there? 4 steps. Right, guys?
Yeah.
Acha ji. Now what happened? If an incorrect digit is input, then the door returns to the locked state. Yes. If you are going to input a wrong value, definitely what happened? The door will be locked again. The algorithms halt when the door is unlocked. Yes, if the door is open, it means the algorithm is halted. Halted means to stop because the door is unlocked. A state transition table shows every state, each possible input, and the state after the input. So now we are going to see a state transition diagram for this algorithm. The state transition table for the door with the entry key 259 is shown. So guys, what is the password? 259. And now we are going to represent this whole scenario with the help of a state transition diagram. Let's see how it looks. Look, first we have a table here. If an incorrect digit is input, then the door returns to the log state. We know this thing, right? And the code is 259. Let's see. Current state. What is the current state of the door? It is locked. What is the first digit? What is the code?
2.
259. So what we have to input?
2.
2 first. Once we input 2, so our next state will be, the state transition diagram is going to wait for the second digit. What is the second digit?
5.
5. Okay, I accept it. But if we are not going to input 2 in the first stage, then the door remains locked. So if I input 5, so it is wait for the third digit. But if you are not going to input 5, the door remains locked. If I input 9, the door will be unlocked and the algorithm halted. Stop. But if I'm not going to input 9, the door again remains locked. But it's a very common thing, guys. पासवर्ड डालते हो लैपटॉप में, मोबाइल में, अगर तुम्हारा पासवर्ड गलत है तो मोबाइल लॉक ही रहेगा, भले तुमने सारे पासवर्ड के कैरेक्टर्स ठीक डाले, बट इफ यू आर गोइंग टू इनपुट any of the character incorrectly, so your password remains locked, just like this. So I teach you every state here. 259 is our key. So this is the table for the inputs. Now let's see the state transition diagram. This is a state transition diagram. अच्छा जी, जल्दी जल्दी बताओ, how to start the state transition diagram? How do I start reading the state transition diagram? Is there any clue?
You start with the dot.
Dot here,
start?
guys. This one, a black dot. It means this is my initial value. And look, the door is locked. So what we have to do? What is the password, guys?
That's 259.
259.
What I have to enter? 2.
259.
क्या कहलाएगा? What is that 2 called? देखो एक arrow है. What is that arrow called?
Transition.
Transition. The arrow is called transition. And this 2 is called
The input.
event. Remember, guys, this 2 is called event. Okay. So look, I input 2, but my door is waiting for the second digit. So I input 5. My door is waiting for the third digit. I input 9. The door will be unlocked. Why there are 2 circles? It means
It's the end.
we have to stop. Acha guys, now let's see, if I'm not going to input the correct password, what happened? Look, if 2 is there, but if there's no 2, so look, this is our first step. And look, if I'm not going to input 2, it is going to be lock again. Look, the back arrow. This is the arrow, right? Lock again. Now I'm going to input 5. If I'm not going to input 5, look, it is moved back to the lock stage again. If I'm not going to input 9, look, the previous stage is going to be lock again. So this is important thing, guys.
Okay.
Got it?
Yes.
Great. What you have to do, take out your notebook, write it down. Let me see if anything missing. Okay, everything is done here. Okay. So what do you have to do, guys? You need to draw this diagram, take a picture of this table. So this table you can do in your homework, okay? But you have to do
Okay.
this diagram, okay? With the comments, I want comments. Like you have to write down the important points by your own. Whatever you understand from my lesson, right?